if we know stem cells exist in the body, in other tissues besides the blood, what we know is that those cells have important roles in making the tissue when we're first forming, developing, also in maintaining tissue, but we don't think of them as doing a tremendous amount in the setting of injury. So there are stem cells in places like the brain. They clearly don't have much ability to restore function in someone who has a stroke. And one of the questions is, if those cells can be identified, can be isolated, can be shown to grow and do lots of different things in the laboratory, why can't we get them to turn on and be more effective to regenerate tissue in somebody with an injury like stroke or like Parkinson's disease? And one of the issues now is to then think about not necessarily taking the cells out, because they live in a very deep spot in the brain, a place where no one really wants to go in and biopsy, that maybe what we can do is understand how to turn them on. So this idea that we might be able to develop medicines that now activate stem cells that we know exist in many of our tissues is an ongoing, very active aspect of research. So you can imagine in that case, what we might be thinking about is not so much using a cell, infusing it, putting it in the place of a damaged tissue, but perhaps just taking medicine, something that we already know a lot about, and now asking those medicines to change the context, to change the signals, the triggers for the stem cell that lives in a tissue, and forcing it to start to become more active and regenerating, rather than just essentially maintaining, rather than allowing a scar to form, actually getting engaged and starting to regenerate the tissue. Now, it may not completely restore function, but if it had a minor effect, it could have a big impact on people's disability and level of activity. There are ways in which this technology could be viewed as something that would be potentially a threat to the pharmaceutical industry. I think most of the pharmaceutical industry is very excited about this area. Their caution comes more from the concern as to whether this, to know exactly how to utilize this new biology in a way that will result in products that can really make a difference for people. And developing products is, of course, a very long sequence of events. When we're dealing with entities that are trying to forestall further deterioration or trying to target particular molecules that are known to be abnormal in a particular disorder, those are paths that the pharmaceutical industry has worked out very well over a long period of time and are clearly outstanding at doing so. How to use the idea of a regenerative process, that's something that's very complicated. And it's still very much in the days of early exploration. So understandably, pharmaceutical companies and generally the commercial side of healthcare has been in the wings, trying to understand, to assess, to really think about how you might be able to actually lay out a path to move forward to the clinic. I think now there are a couple of developments in the field where the pharmaceutical industry has started to get engaged. One of them is this idea that we can make models of diseases in a petri dish. That, of course, then becomes terrific raw material for drug companies to be able to use it and try to develop new therapies. And we've clearly seen that large pharmaceutical industry players are getting actively involved in that. And that, I think, is a real advantage for them and for the field. This idea of using drugs to regenerate tissue, activating what are the stem cells within, that's an area that they're just starting to pick up on. And I think that's still, it's still complicated models. And in general, the pharmaceutical industry doesn't have these complicated animal models in-house. And so they need to partner with academic teams that work on those things. And that's starting to happen as well. So I think we're starting to see that what used to be a purely academic endeavor, and frankly one limited to the number of academic centers that could get around some of the limitations that government funding had in the field, is starting to break. And now we're starting to connect both with other sources of funding in terms of the academic enterprise, but also bridging the gap into the commercial world, where we're starting to really think about what are the applications that might turn stem cell biology into stem cell medicine. And that's clearly a critically important component of the work of the next 5 to 10 years.